Our topic of today is sampling and sampling distribution. I am assuming that you are already through with measures of central tendency and dispersion as well as probability distributions. There will be slight applications of measures of central tendency and dispersion, and there would be significant applications of probability distribution, especially normal distribution. So, if you have not gone through or if you still need certain help, so please go through, be comfortable in normal distributions, and then we can move to sampling and hence applications of sampling distributions. Sampling we apply in everyday's life. Before we enter more to sampling, let us have certain basic concepts. Basic concepts include population, sampling, parameters, statistics. Starting from population, population we refer as the whole group of people under study. Sample is a subset of the population. It comprises only the elements, some elements of the population, and then if we talk about sampling unit, it is a single member of the sample. Sampling hence is a process of selecting an adequate number of elements from the population, so that the study of the sample will not help in understanding the characteristics, but will enable us to generalize it. Then census is the complete study of the population. There are various situations where we apply sampling. Most of the time there are few situations where we apply population census as well. For example, every 10 years we calculate the population of the country. That counting includes census. There are certain more concepts. Parameter, any measure we calculate, any statistical measure we calculate from the population, that is a parameter. For example, if we have population size, that will be capital N, population mean, that will be mu, population variance, sigma square, population correlation coefficient, rho. So, if we talk about IIT, if we take an average marks scored by each and every student in BTech final year, that will be population data. But in case if we measure only say mechanical engineering, some 10 students picked at random, that will be a sample data. So, 10 students would be a sample size, all the students in IIT graduation final year would be population size, and then mean of those 10 students would be x bar, mean of all the students in the final year would be mu, mean of the population. Then certainly there are many advantages of sample over census. These advantages include time and cost. You save a lot of time, and certainly cost is saved, and hence whatever information you are generating from sample, that you can generalize to the population. There are even situations where only sampling is possible. For example, when you go for shopping, you have to buy certain fruits, say for example grapes. You can not test each and every grape and then buy. Hence, sampling is the only option, and even during crackers, if you want to test whether the sound of the crackers you bought is certainly significant or not. So, if you want to test before Diwali, so you can only test one or two, you can't test each and every one, right. Hence, there are significant sampling applications, and as far as population study is concerned, that is more appropriate when it is mandatory. It is very important to go for only population, we do not have any other option, or when the population size is small. Types of sampling, we can categorize this into random, non-random sampling, or probability, non-probability sampling. Probability sampling means there is certain probability of each and every element of the population to be selected in the sample. Probability is known in advance, whereas in non-probability sampling, probability is not known in advance. It will be researchers' discretion to include which element, not to include which element. Moving to the probability sampling first, if we have to take various types of probability sampling, this will include simple random sampling first, simple random sampling with replacement, simple random sampling without replacement, then systematic sampling, stratified sampling, and cluster sampling. In simple random sampling, say if we talk about a pack of cards, we have to say draw 2 cards. If we draw the first card, we just look at the color and replace it back, that is with replacement. Then the probability of selecting the second card is independent of the first card selected, because now it is again a fresh pack of cards. There are 52 cards, the first card is replaced back, that is with replacement. So, with replacement, the other term used can be it would be a sort of independent situation. First card would be independent of the second. Then without replacement, if we talk about, in without replacement, if we draw first card and don't replace it back, then we are left with only 51 cards in the pack of cards. So, the second card drawn would certainly depend upon the first card we have. That is simple random sampling. In systematic sampling, it is in 2 stage. One, we arrange the total, you can go through the details we have in PPT. In systematic, it is 2 stage. Once we arrange the total data into in certain order, then we will look at the population size first. We will also look at the sample size we need to have. Then here we will define a sample interval that would be k, say capital N by small n. For example, if we have say population size of 100, we need to select a sample of 20 out of it, then k would be 100 by 20 means 5, right. So, that would be a sample interval. So, there would be 20 such sample intervals of 5 size each, because our population size is 100. Then from every such sample interval, we will select one number at random, say that number selected here is S, say it is 3. Hence, the remaining elements of the sample would be 3 plus k plus 2k and so on. So, hence those numbers would be 3, 8, 13, 18, 23, and then that total load would be a sample with systematic sampling. Moving to stratified sampling, here we have one understanding in mind that population is very heterogeneous. By applying stratified sampling, we will try to categorize that population into homogeneous groups, and then from every such group we will have some contribution to the sample. For example, if a physician wants to understand all the patients who visit him, what is the duration of sleep they have. So, then he may like to first categorize the patients visiting him into, say in the kids, say up to 12 age, then 12 to say 18, 18 to 30, 14, 30 to say 50, 50 and above. Then from every such categorization, he will have certain sample that will totally contribute to the single sample we would like to have. This stratified sampling can be proportionate, it can be disproportionate. Say in case of proportionate sampling, the size of sample drawn from each stratum, the single segment would be a stratum, is proportionate to the relative size of the stratum in the total population. Whereas in disproportionate, it may not necessarily be a relative size selected. Then moving to cluster sampling, there is a slight difference between stratified sampling and cluster sampling. In stratified sampling, we talked about that the population is heterogeneous and we categorize that population into homogeneous groups, and then from every such group we pick some contribution to the sample. Whereas in case of cluster sampling, we understand that within the population some homogeneous clusters exist. So, that cluster means they are between homogeneous. In case of stratified, groups were between heterogeneous and within they were homogeneous, whereas now in clusters between they are homogeneous, but within they would be heterogeneous. For example, we took a situation of patients visiting the doctor, and that was a stratified situation, heterogeneous between. Now, in case of clusters, if we talk about, say the industrial sector in Noida and say Udyog Vihar in Gurgaon. So, we may feel like that these are similar sectors. So, there is a homogeneity between, but within the kind of companies or firms in the industrial sector in Noida would exist, they may not be the same in case of Gurgaon. So, hence I am repeating, the main difference between stratified and cluster sampling is, in stratified sampling it is heterogeneous between the groups, and within the groups they are homogeneous, and in cluster sampling they are homogeneous between and heterogeneous within. So, from every such cluster we will have, first the clusters are selected, then in the second stage we will have probabilistic approach of selecting some portion to the sample, and then we will get a complete sample with the help of cluster sampling. So, we have till now discussed the probability sampling, all 4 types. Now, moving to non-probability sampling. Non-probability sampling, like we are discussing, here the elements of the population do not have any known chances of being selected in the sample. We can categorize the non-probability sampling as convenience sampling, judgmental sampling, snowball sampling and quota sampling. Convenience sampling, as the name suggests, is mainly based on the convenience of the researcher. Here respondents are selected as requirement of the researcher or the manager, because they happen to be at the right place at the right time. For example, if you go to a mall intercept interview, so anybody who is approachable, you would like to have some information from him, and then again you are looking for certain people on the street and you have certain general questionnaire. So, anybody you meet, you may like to have the information from him or her, and hence that will contribute to the convenience sampling. Judgmental sampling, here it is also a sort of convenience sampling, but the population element selected will have certain judgment of the researcher. So, that is why we call this a judgment sampling. For example, as a manager, if he has to apply any manipulation to the independent variables that contribute to the sales, the variables that can contribute may certainly include advertisements, that may include promotion schemes, the celebrities you have, what kind of events you organize. So, you may pick certain test market, you will organize certain promotion event, and hence that is the judgment of the researcher. So, this kind of picking of a market will include judgmental sampling. There are many more examples that may be expert witnesses used in court, purchase engineers selected in industrial marketing research. Moving to then quota sampling. So, it is a 2-stage restricted judgment sampling. So, we have one understanding that we would like to assign certain quota to certain set of people in the population. For example, simplest way can be in case of male and female. Say if we want to assign a quota of 40%, say we would like to have males and 60% females. So, hence accordingly then we can select at random out of male 40% and out of female 60%, that total will include our 100% sample. Then moving to the last type, snowball sampling. Snowball sampling we apply when our population is quite rare. In that case, what we will do is we will select an initial group of respondents at random. For example, if you want to have certain survey of the set of population, the people who drive Harley Davidson bike, right. So, this would be certainly rare. So, we will pick initially 1 or 2 at random, then after interviewing them, their responses to our query, will request them if they can refer us some more whom we can contact. So, it is also a sort of a referral sampling. After understanding the probability and non-probability sampling under types of sampling, we move to what kind of errors that may arise when we apply sampling in case of census survey. So, we are trying to save the cost, we are trying to save the time, and in that process there may be chances of sampling error, there may be chances of certain non-sampling error. So, we need to be very cautious that we should try to minimize both. Sampling error arises when sample is a non-representative and any error because of the technique you picked. So, to reduce that, we must always keep in mind that whenever we select a sample, it should be the close to a very large sample, very large possible sample, right, as per the availability of time and resources. Hence, we can minimize the sampling error. The smallest the sampling error would be larger, and larger the sample, sampling error would be smaller. So, there is an inverse relationship. Non-sampling error, this will arise mainly because of human errors, say plain lying by the respondent, that will certainly contribute to an error. The error may arise while transferring the data from questionnaire to spreadsheet, your typing error. There can be certain errors can be at the time of coding or computation. So, whatever errors are with human touch, that will be under non-sampling errors. So, after understanding those errors, and when we were sharing that sampling error can be minimized by maximizing the sample size. So, what should be the adequate size of sample? There are various studies on this. Certain study says that if your sample has say 20 questions, so your sample size should be at least 5 times, that is in a layman language. But you would like to understand in terms of the statistics, in terms of the variability of the population, the confidence attached, the permissible error we can have, then taking them one by one. Variability, we understand the higher the variability means standard deviation is very high. So, larger sample size would be needed. If a confidence attached to it, how much confident we would like to have, that sample represents the population. So, again for larger the confidence, larger the sample size would be needed. And if we want to have minimum allowable error, here allowable error means the difference between sample statistic and population parameter should be minimum. Say when we are taking an example of IIT BTech final year students, their marks scored, then those 10 students is a sample information, total students are population information. The difference between these two should be minimum, that is allowable error. So, if we need more accuracy, larger sample would be needed. Those alone 10 may not be able to reduce the error, right. Then we would like to try to convert this to a formula shape. If you look at the z value under the formula of sampling distribution, we will come to that. That is x bar minus mu by sigma over root n. If you simplify that, I will repeat this thing there as well. If you simplify that information, then n would be z square e sigma square by e square. Here e is the margin of error. This is x bar minus mu, sample information minus population information. Then from there we reach this formula, and z is the kind of confidence we would like to have, population standard deviation information we have, and then we can calculate the sample size. That was in case of average, mean. We can also calculate this in case of proportion. Proportion we understand is the certain kind of characteristic people have out of the total population, right. Say if we talk about in IIT, how many students nowadays get admission from Delhi. So, the students who are getting admissions from Delhi out of the total, that would be proportion of students from Delhi, and hence we can have P as well as we can have Q. Say if out of 500, 100 are from Delhi, so 100 by 500, 1 by 5 would be P, and 4 by 5 would be Q. Hence we can use P and Q here to get the population size. And in case even proportion information is not given, then we will assume that P is half as well as Q becomes half. Then the sample size formula would become 1 by 4 z square by E square. So, we have discussed in total 3 formula. This is for population mean and another is for population proportion. Then we have certain questions that can be solved. I am just taking 1 or 2 questions here that certainly you can easily solve them by taking help of the formula. If you look at the first, an economist is interested in estimating the average monthly household expenditure. So, here he is interested in estimating average monthly household expenditure on food items by the households of a town. Based on the past data, it is estimated that the standard deviation of the population on monthly expenditure of food items is 30. So, population standard deviation given me sigma is known to us, which is 30 with an allowable error is 7. That means x bar minus mu or E is 7. Estimate the sample size required at 90% confidence interval. Now, we understand sigma and E. Then there is another information given related to the 90% confidence. So, here you will need the application of concepts of normal distribution that we have already covered. So, 90% confidence, if you look at the z value at 90% confidence means 45% lies to the left and 45% lies to the right. So, if you look at the z table, 90% total area equally distributed around the mean value, and that z value is 1.645. So, hence in this formula, if you take z value as 1.645, sigma was here, sigma was 30 and allowable error as 7. Then you can be easily sure under 90% confidence how much sample size you must pick. So, that sample size can be calculated, that would be 50. And then say if we take another question, say question 4th here, a consumer electronics company wants to determine the job satisfaction level of its employees. For this, they ask a sample question, are you satisfied with your job? It was estimated that no more than 30% of the employees would answer yes, right. So, they are not talking about any average, they are only talking about certain characteristic of people who answered yes. So, 30% answered yes means proportion of people who answered yes is 30% and Q would be then 70%. P is 0.30, Q would be 0.70. What should be the sample size for this company to estimate the population proportion to ensure a 95% confidence in result and with 0.04 within 0.04 of the true population proportion. So, here we have population proportion given, they are expecting us to have the sample size at 95% level of confidence and within 0.04 of the total population proportion means allowable error is 0.04. Then from here we need to calculate z value at 95% confidence. Then if we look at the normal table, 95% means 47.5% on the left side, 47.5% on the right side, total 95%. Those cut values would be 1.96. So, if you take that 1.96 as z value and 0.04 at the allowable error and P would be hence 0.3, Q would be 0.7. So, you can calculate the sample size expected, right. In the same way, second and fourth example can also, second and third example can also be attempted easily. Moving further, after understanding those basic concepts of sampling and how to calculate the sample size, we would like to now understand sampling distribution. We are already through with probability distribution, where we studied binomial distribution, Poisson distribution and normal distribution. So, similarly, sampling distribution is also a probability distribution. The only difference here is that it is defined as a probability distribution of all possible means of the samples is the distribution of sample means. I will repeat in more simple way. Before that, we understand whenever we have a population, say in Delhi, if we talk about a sample size of 50 youngsters from various colonies, we would like to understand the daily spending habits of youngsters. So, we pick a sample size of 50 from say Lajpat Nagar, 50 from say Rajouri Garden, 50 from say Mayur Vihar in East Delhi or Rohini. Then all such samples may have different averages, different daily spannings. Now, there is quite a variability in the sample means we have, right. So, the distribution of all the possible means of that sample, from Lajpat Nagar we have different average, from Rajouri Garden we have different average, from Mayur Vihar we have different average, from Rohini we have different average, and from various other places. So, we have so many different averages. Those averages can be x1 bar, x2 bar, x3 bar, xn bar, and maybe the total possible samples from here. So, now the variability in those x1 bar to xn bar, now these will be all means. That variability, that probability distribution of variability is sampling distribution of the mean. In the same way, if we talk about proportions, then that would become sampling distribution of the proportion. So, we have two things to cover under sampling distribution. Let us take them one by one. There will be a concept of standard error that will apply in both again and again. Like we were saying, when we have those n averages, there is maybe a quite of difference from Lajpat Nagar or Rajouri Garden or Mayur Vihar or Rohini. Now, the variability, the variation in the average values from all these locations, that variability of the samples, right, is called standard error. We understand standard deviation is the variability of the population. So, standard error is similar to standard deviation, but now standard error is the variability of the sample. So, we just keep this in mind. Standard error represents variability of the sample, and it is a sort of variability similar to standard deviation of the population. Then to understand that in formula term, standard error of sample mean we define as sigma, we denote this by sigma x bar would be equals to sigma by root n. So, here we understand standard error would decrease with increase in the sample size, and it would increase with decrease in the sample size. So, it is inversely proportional to, standard error is inversely proportional to the sample size. We will continue with this concept of standard error under different possibility of population. First, if the population is normal, then population mean is mu and standard deviation is sigma. Then we will assume that samples that we have drawn from the population are also normal, and hence the sampling distribution would have the average mu x bar, I mean mu of those, all those averages would be equal to mu, and standard error would be sigma by root n if the population is normal. Then, like we were having standard normal variate in normal distribution, that variate you remember was x bar minus mu by sigma. We are subtracting mu from sorry, that was x minus mu by sigma, because x was the random variable and we were converting that to z. So, x minus mu by sigma here now becomes that random variable x is now replaced by x bar. So, x bar minus mu by sigma. Here sigma means the variability, and variability of sampling distribution is standard error. So, sigma here of x bar would be sigma by root n. Hence, z value for sampling distribution would be x bar minus mu by sigma over root n. You understand these terms? Then we have certain sampling distribution properties. like we were saying, if the population is normal, so automatically the sample will select from the population would also be a normal, and hence the standard error would be sigma by root n. In case the population is not normal, but the sample size is large enough, here large enough means sample size is say more than 30, then again by applications of central value theorem will consider that sample also approximately normal, and hence in that case also its variability would be sigma by root n. Standard error, please remember, is a variability, it is not that tough technical term, it is simply a variability like standard deviation. So, we are talking about central limit theorem. It says as the sample size gets large enough, here large enough means 30, then initially this blue color curve is not a normal curve, it is a skew curve. I hope you know this, it is not symmetrical. Then sampling distribution becomes normal regardless of the shape of the population. If your sample size increases, it goes 30 plus, then your population would be assumed to be normal, and hence its sample will have a shape of the normal distribution. So, if the population is not normal, here we are repeating the same thing to have better understanding. Smaller the sample size, curve is skewed, larger the sample size, curve becomes normal, symmetrical curve. So, that we have till now discussed two cases, one population normal and population not normal. Under population not normal, if sample size becomes more than 30, then it will assume a normal distribution. An example here, suppose a population has mean 8 and standard deviation 3. Suppose a random sample of 36 is selected. So, our random sample is 36, it means n is greater than 30, mu and sigma are given. What is the probability that sample mean is between 7.8 and 8.2? Here we have to calculate the probability of sample mean between 7.8 and 8.2. Now, this is a similar situation like probability distribution, normal probability distribution. There we discuss if a random variable is distributed normally with mu as mean and sigma as the standard deviation, then we can calculate the probabilities between any two random variable values. Here it is a normal distribution for sample mean, and hence we can calculate again any probability between any two sample mean values. They like us to calculate between 7.8 and 8.2. So, our steps would be similar. We would first convert the given random variable into z value, and then between those z values we would calculate the probability. He has also asked related to the probability between 8 and 11. I am helping you in solving one. Second, I would ask you to solve it yourself. In case you are not able to solve, or if you are not able to understand, you need more clarity on any of the concepts we have just discussed, then you can drop me a mail in my mail ID given in the first slide itself. So, our requirement here is that we need to calculate the probability between 7.8 and 8.2. Before there we would be using in the z value we discussed here x bar minus mu by standard error. So, we will first need the standard error, and then with using this z for x bar equals to 7.8 and for x bar equals to 8.2, we can calculate respective z values. So, you must keep this, you must write this formula on a paper and then substitute those values. Here those values are mu is 8 and standard error is 0.5 if we apply sigma by root n. Then using that formula of z, initially it is Given we need to calculate between 7.8 and 8.2. If we use that formula here, we substitute in terms of z. This is z mu x minus mu by sigma by root n, and this is the upper limit. So, it becomes between minus 0.5 to 0.5. And we must sketch a curve like I shared my previous class. So, here if you sketch the normal curve, we were expected to calculate between 7.8. 7.8 would be on the left side of mu, mu here is 8, and 8.2 because it is greater than 8 would be on the right side. This shaded region we need to calculate. This is given status, we will like to standardize this. When we standardize this, it becomes in terms of z values now. It was initially, this is an important step, I already covered that in normal distribution. I am repeating, it will be helpful in normal distribution too. So, initial status is in terms of the random variable, here the random variable is in terms of mean, that you standardize in terms of z. When you standardize in terms of z, the central value is 0, negative values are on the left side, positive values are on the right side. Then you after plotting this, you look at the normal distribution table, look at the values from 0 to 0.5, because normal distribution table gives us the values from 0 to any upper limit. So, you will get the area from there, or you can simply say the area between minus 0.5 to 0.5 is the double the area from 0 to 0.5. So, one way is separately you get the area like it is given here, and area is always positive even if you are taking from negative value to 0 or 0 to positive value, it is always positive, you can add them, it will be 0.3830. So, hence we are expected to calculate the probability between 7.8 to 8.2, that using this process is 0.3830, 38.30%. For second part also you can calculate that probability. So, in this way we have covered the sampling distribution of mean when the population is normal or sample size is large enough. Now, there is one more case, if population is not normal and even the sample size is small, or the population itself is small, that you are not able to get a sample size more than 30. Say if your population size itself is say 20, say from 20 locations you need to select certain localities, say you select only 5 localities and study them, say your sample size is 5, locality is study we are talking about out of 20. So, what will we do in that case? So, in that case central value theorem is not applicable. So, we will need certain adjustment, that adjustment needed is applied with the help of the finite population multiplier. The finite population multiplier is defined as the population size minus sample size divided by population size minus 1. So, whole under root, this is the finite population multiplier. Initially we had standard error as sigma by root n, now we will multiply with this and that will result into the standard error under this case. Okay. So, this is one case, and how to decide whether the population, say we were talking about 5 colonies out of 20, whether that 5 is smaller or larger than in comparison to capital N. So, we have a direct understanding on this. To apply this finite population multiplier, we must use correction factor when n is more than 5% of capital N. N small n means sample size, capital N means population size. Say our population size is 20 colonies, we would like to study 5 colonies. So, 5 out of 20 is how much percent? 5 means 1 by 4, it is 25%. So, that 25% is more than 5%. Hence, we can say if whenever it is more than 5% of the population, we will apply finite population multiplier. So, the only difference would be in the total calculation, your Z would be now x bar minus mu divided by not just sigma by root n, even into sigma by root n into finite multiplier, and then rest remaining calculations are all the same. I hope it is clear. Then moving further, that was sampling distribution of mean. Now the final topic for this lecture is sampling distribution of proportion. Proportion, we understand proportion of the population having some characteristic. Say we are taking the same example, how many students these days are able to get admission to IIT Delhi. Say if 100 are able to get admission, out of 500, that is the proportion of students from Delhi 1 by 5, and not getting admission is 4 by 5, that is for population, exact data we have. But in case if we pick say 20 students just getting admission to IIT at random, and we find that 5 were from Delhi. So now sample proportion would be 5 out of 20. So 5 out of 20 would be 5 by 20, 1 by 4, and that is small p, and small q would be then 3 by 4. Okay, so in this we have, in this form we have capital P and capital Q, also small p and small q. Now those both small p, small q and capital P, capital Q follows a binomial distribution. In sampling distribution, we will approximate that binomial distribution with the normal distribution. We will assume that probabilities are distributed normally. Say if the probabilities of happening of different probabilities of 0.2, are 0.2, 0.4, 0.6, 0.8 and 1, and so we will assume it is distributed normally. The highest is at 0.5 and lowest it is at extreme. When we are assuming so, then our average becomes capital P and sigma. The standard error now would be PQ by N. Now moving to the sampling distribution of proportion. For that sampling distribution, we need the Z value. That Z value is earlier it was x bar minus mu by standard error. Now x bar is in form of x bar was what? Was a statistic or parameter? X bar was statistic. So hence small p is a statistic here, capital P in place of mu is a parameter, and divided by standard error of this proportion. So small p minus capital P by PQ by N under the root. This will be our Z value for proportion. This is the case. This is one case, and second case, if your sample is without replacement and n is greater than 5% of the population size, like we were saying, if we have to just select 5 colonies out of 20, our population itself is 20, sample size of more than 30 is not possible. So we can't apply central value theorem, and hence we need certain adjustment to the variability. So whenever that is the case, small n is greater than capital N, then we must look for a finite population multiplier here, and that will get the standard error as PQ by N into capital N minus small n by capital N minus 1. So there are just two cases we must remember here in case of proportions. To have the applications of these, let us have an example. If the true proportion of voters who support proposition A, true proportion here means we are talking about population or sample. True proportion means we are talking about population. So capital P is 0.4, and hence capital Q would be 0.61 minus capital P. What is the probability that a sample of size 200 yields a sample proportion between 0.40 and 0.45. So here sample size is given 200, and we need to calculate the probability between 0.4 and 0.5. In such questions, like this information is very important, please listen carefully, pay extra attention. This differentiation, one was of normal distribution, another is of sampling distribution, and in sampling distribution in case of mean, and third is of sampling distribution in case of proportion. So, how to distinguish? In case of normal distribution, only the random variable x is given, and they expect us to calculate probabilities for the random variable x only. They do not ask to calculate probabilities for averages. Whereas, in case of sampling distribution for mean, the variable is the mean, the sample mean, and the probabilities are required to be calculated for sample mean only. Then moving to the last, proportion, the variable under study is proportion, not mean, not just variable alone. So, for example, in this case it is proportion we are studying, we are not nowhere talking about average. So, whenever we have to calculate probability of proportion, then we will apply sampling distribution of proportion. So, for applying that, we will have the standard error first. So, standard error, if we have to calculate, here sample size itself is 200, one it is greater than 30. So, we will take the case that there is no need to apply the multiplier. So, the standard error would be p into q by n. So, that is p in q means 1 minus p by n. So, you substitute the values, see what results come, that is the standard error. Moving further, we have to convert that proportion values into z values. Z we discussed is p minus capital P by p q by n. So, we will use this formula to convert given p values into z values. This probability is expected. This is in terms of given variable here is proportion, given proportion. That given proportion needs to be converted into standard normal variate. So, if you convert that to standard normal variate, lower limit becomes 0, upper limit becomes 1.44. So, in any of these situations, whether normal distribution, whether sampling distribution, whether sampling distribution of mean, or whether sampling distribution of proportion, once you have the values in terms of z, then you need to take assistance of normal table. So, normal table, you just look at the value at 1.44, get that value, put it here, that will be your probability. So, if you look at normal table, and also please you must sketch this curve between the original limits. Original limits were in terms of p 0.4, 0.45, and the standardized normal limits would be 0.425. You must sketch at least one curve. You can say this is p here, you can say this is variable p. Just before this you can write variable z, z will be here 0, here it will be 1.44. So, sketching one curve also is sufficient, that will help you in the complete understanding. So, we need this area. So, it is common sense, starting from 0 up to 1.44, look into the normal table, that value comes out to be 0.4251. So, in this way we can handle cases related to sampling distribution for proportion. So, having a quick review what we have studied till now, we started our session with sampling and sampling distribution. We discussed what sampling is, why it is important, why it is useful in comparison to population. We discussed various concepts of sampling. Then we have studied types of sampling. Probability sampling is a sort of a rational approach, unbiased approach, and non-probability sampling, also non-random sampling it is called, is a non-rational approach, or sometimes also called bias, but sometimes we have to apply bias. Biased is here a subjective approach, we have to apply that experience, the requirement. So, sometimes that is in the positive sense, that subjective approach. Objectivity otherwise is expected. So, after understanding those probability and non-probability sampling, we have then moved to the errors, sampling and non-sampling errors. Then we picked how to calculate the sample size. So, you need to keep in mind what the formula for n is and how we can just substitute those variability and z values to get the sample size. Then we move to the sampling distribution. Sampling distribution is same like probability distribution. So, sampling distribution of proportion can be calculated, sampling distribution of mean can be calculated. Here concepts of normal distribution will play an important role, and in the normal distribution those 5 steps applications were the given variable you need to convert in terms of z. So, you convert that variable for the lower limit as well as for the upper limit in terms of z, you get the variables in terms of z here. Once you have those variables in terms of z, you sketch them, whatever area you need you sketch them, then with your common sense and with the help of normal distribution you will sketch, you will get the values, and that will give you the answer. With that we come to the end of this session. Thank you.